Okay, as we already mentioned last week, so we will have at least two presenters. So for today will be two presenters. The first one is Gansu, and the second one will be Jonathan. Uh, so we are now 21st December. We will have another lecture tomorrow. Tomorrow will be Ardian, but let me check how many we will have. Okay. Um, okay. So today two, tomorrow one. Uh, if today three presenters, is that okay? Three presenters today. So the third one will be Ardian. Is it okay, Ardian? Okay. So the first one, I think I can let the first speakers to present the presentation. So yeah, uh, I think you can talk now. You can, Kansu.
Okay, can everybody hear my voice?
Yeah, your first is okay.
Oh, okay. Hello, everyone. Now I'm going to show you a summary of my topic. And my topic is sequence. And sequence is just a list of numbers. And in my topic, there are some sequences have no pattern, and there are two typical sequences. The first one is arithmetic sequence, and that means the terms differ by a common difference, and we write it as D. And the second typical sequence is a geometric sequence. That means terms have a common ratio. And I think in my video, I have already shown you some examples, and it's not so difficult to understand. So then I will show you some application of sequence in our real world. And for arithmetic examples, time on clock, each minute hand that the second and the second hand covers in 5 seconds. As 5, 10, 15, 20, 25, 13, and to 60. And the second example is the point at which a runner passes the finish line in a 3,000 meter race. It's, for example, it's 200 meters, 600 meters, 1,000 meters, 2,600 meters, and finally to 3,000 meters. And for geometric examples, there are also two I want to show you. One is the half-life of carbon or any element. You can then show how all the carbon-14 is depleted over thousands of years. And the second is again the time values in the game 2048. Tie 1 is 2, tie 2 is 4, and tie 3 is 8, and so on. Uh, and thanks for listening. Okay, that's all.
Okay. So I will let everyone to have some questions or any discussion. Okay. So please, if you want to speak, You can speak or you can write on the chat box. Okay. Okay, any questions? Okay. Okay, there's one question from Hans. Maybe you can try to answer.
I think in the future, the sequence will use in the calculus. Yes, for the arithmetic examples, the difference can be a negative number.
Okay, any other questions? Yeah, I think calculus is one example that will use a sequence. Okay. Yeah. Other example. Other questions? Do you have any other questions? Okay, so there are at least, as mentioned in the presentation, at least there are two types. Okay, in general, that is the arithmetic sequence and geometric sequence. Okay, but actually there are more. Okay, but the one that is familiar is those two sequence, the arithmetic and geometric. Arithmetic is you have the difference, okay, in between the numbers. Geometric, you have a ratio, common ratio. You can multiply or divide with some numbers. Okay. Um, Maybe I can show you some for maybe 5 minutes before the second presentations. Let me make some summary. Okay, what is the key points in the presentations? So let me go through. Okay, so I hope you guys can see my notes here. So the first one is the arithmetic. Okay, arithmetic sequence. Okay, and it start from if you have a number 1, 3, 5, 7, 9, 11, and you see that this is a plus 2, plus 2, plus 2, plus 2, plus 2, and you can simply write down uh, the list as the first terms is a, the second terms is a plus d, the third term is a plus 2d, and so on. Okay, and you get that a for every in every list of n, it will be the first terms plus n minus 1 and d. Okay, d will be the difference. Okay, the difference like this one, the difference is 2. D is 2. Okay. Okay. Now, if you have so aside from just a sequence, we have also sum. Okay, sum. So if you have, for example, sum from 1 plus 2 plus 3 plus 4 plus until 100. Let's write 100. Okay. If we plus this, okay, with another one with the same exact numbers but different orders, so we start from 100 plus 99 plus 98 plus dot, 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 plus 3 plus 2 plus 1. Okay, so if we add these two, should be the same, right? Should be twice as it is. But let's just add this. So this will be 2s. You look here, 1 and 100, 2 and 99, 3 and 98, they all having 101. Okay, so plus 101 plus 101 plus dot 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 until the very end, it will be the same 101 plus 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 plus, right? So the question is, how many n is this? We have n is from 1 until n is 100, right? So we are actually get this is 101 multiplied by 100, the n. Okay? And our s will be, and this is yeah, equal with this number. So we can also have we call this sum, okay, or Sn is n over 2 multiplied by 2a plus n minus 1 d. Or we can write down as a plus an over 2. Okay, so that is the arithmetic sequence. Okay, now the second one, okay, the second one is the geometry. The geometry sequence is the first term is a, and then the second term is multiplied by some ratio r, and the third one, the fourth one, and so on. Okay, so r will be the common ratio. And the general formula will be a r n minus 1. Okay, like we have 3, 6, 12, 24. This is multiply all by 2. Okay, and similarly we have the also the sum, the Sn. So let's write the Sn, a plus a r plus a r squared plus dot 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 plus a r n minus 1. Now we add another Sn, but we multiply with r. Okay, and let me write the first terms become AR. Let me write a little bit right like this, so you can see that the what's the results. Okay, and this is the second one is the third, and then you write dot 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 a n minus 1, and then it multiplied by r. It should be a r n. Okay, so I write the second equations a little bit shifted to the right. Okay, and we try to minus this. Okay, we minus, so this is becoming Sn minus r Sn equal a is still a. Okay, and this part will be cancelled. Oh, sorry, this should be should be okay, and this one cancelled, and all this cancel, and this one cancel. So the equations become a minus a r with power of n. So Sn 1 minus r, a 1 minus r n. So Sn is a 1 minus r n over 1 minus r, and r should not be equal to 1. So this will be the partial sums. And you can also imagine if the n gets larger. When n is getting larger or getting infinity, this equation seems, if we calculate it using limit, or maybe imagine that it's getting larger and larger, this becomes going to be 0. And r should be in terms of from 0 to 1. So it should be in a fractions. Okay. So you will get the Sn, and also in infinity and or in large n, this can be 1 minus r. But this is should be the r is in a fractions. Okay. So you have the geometric sequence, you have the arithmetic sequence, and I hope you guys can understand on the concept. Okay, because the idea of for what, Helen? I just saw the message, the chat box. Four types sequence, you mean? Yeah, but the most common in the terms of patterning is these two: arithmetic and geometric. The Fibonacci and the harmonic. I don't think harmonic is going to be because those two is we sometimes, like Fibonacci sequence is it's unique at itself. Okay, so the most common is arithmetic and geometric sequence. The Fibonacci and okay, sorry for the connection. Okay, bad. Okay, going back here. Okay, the next one. I think I will go to the next presentations. It's Jonathan.
Hello, Prof. Can you hear me?
Yeah, sure. Okay.
All right. Binomial theorem. To begin with, what is a binomial? So, binomial is any kind of expression of a plus b form. Here are some examples of expanding binomials. So, a plus b, the first power is a plus b to a plus b squared is equal to a squared plus 2ab plus b squared, and the same goes on. There are two methods that I'm going to explain on how to expand these binomials. So the first one is the Pascal triangle. So this one is the Pascal triangle, and actually the first row is like the zero row, and the second one is the first, and it goes on. So how to find, for example, this question, a plus b to the fourth power. So how to use this Pascal triangle to expand these binomials is just find the row that has the same number as the binomial power. So in this case is 4. We find the fourth row here, and these numbers are actually the coefficient for the binomials. And for the a and b, actually it's pretty simple. For a, starting from the left, the power is the same as the highest power of the binomial, and then it just decreases one by one until it reaches 0. For b, it works the same, but it is just reversed, so it starts from 0 and then to the highest power. Then after we simplify this, we get this. But the Pascal triangle method is not really efficient because this method only works on low binomial power. For example, what if we want to count a plus b to the 20 power? If we want to use the Pascal triangle, we need to count until the 20 row, and it will become very, very big. So there's another method called binomial theorem, but before going there, I need to explain about the binomial coefficient. So the n with the exclamation mark here is actually called n factorial. And how to count this factorial is just simply multiply the number by below any natural number. And we also declare that 0 factorial is 1. Why is that? Because if we see here, like this, 6 factorial is actually like 6 times 5 factorial. And if we want to find 1 factorial is equal 1. And I can also say that 1 factorial is equal to 1 times 0 factorial. So in order to 1 factorial equal to 1, 0 factorial is, it has to be 1. And this is the formula for the binomial coefficient. So this is the formula for the binomial theorem. I'm going to give you an example again. A plus b to the fourth power. You can just put in the formula, and then the coefficient, we use the binomial coefficient method that I was explaining before. So we need to count this coefficient first. So for the a and b, the method is the same as the Pascal triangle. And then we need to count all this. This all is like the coefficient, and then we just put in here. And the last one is the application of binomial theorem. So the first one is it can be used in the field of economics to calculate or to predict the economy in the future. For example, maybe it can be used to count the GDP. because binomial theorem is actually like some kind of pattern, so you can count or predict the economy in the future using this. And the second one is it can also be used in computing areas. Uh, it can be used to distribute the IP addresses and virtual IP addresses. Uh, that's all.
Okay, thank you, Jonathan. I think it's very clear, and I believe most of the sections already been covered for the concept of binomial theorem. Uh, the uh, the theorem itself is sometimes is presented in a application in calculus. Okay. However, you need to learn it by yourself, the binomial theorem, because I believe most of you already familiar with the theorem. Okay, and I think there are more and more applications to this theorem. Okay, and let's open the discussion. Okay, for students who want uh, to to ask or to discuss. Okay, you can write on the chat box. Okay, anyone? Any questions? Anyone? No questions? Hello? Anyone? Any questions for Jonathan? Remember, I already telling you that last week you need to at least prepare for each participant questions. Okay, and I don't think you are preparing your classes very well. I know you're still most of you freshmen first year, but try to prepare in a uh, more well mannered. Okay, I know there's a lot of course difficult to manage all by one, but please, if I'm telling you that you need to prepare at least for some discussion, then please prepare. And I don't think you already see all other videos, right? Maybe few students see, but I don't think most of you see your friend's video. Am I correct? Okay, let's see how the semester ends with your final in basic math. It's 0 credit, but still, if you fail, you need to take another basic of math. Okay, okay, let's going through uh, the third presenter. Let's give to Ardian. Okay, so please, Ardian.
everyone. Now I'm going to explain about polar coordinate. So polar coordinate is a different way to locating point in a plane. In polar coordinate, we specify the location by r, or the distance of the point from the origin, the pole, and theta, the angle from the positive axis. This is the difference between polar and rectangular. While polar we use r and theta, in rectangular we are using x-axis and y-axis. For the example, for this one, we just need to see that there's a 3 circle, so the r is 3 and the theta is 120 degree, or we could write as 2 per 3 pi. There's a different way in plotting points in polar coordinate. For example, like this one, there's a positive r and minus r. In minus r, we just need to flip it 180 degree from the origin. And if we have a minus r and minus theta, so we need to first read it from the angle, then we can flip it for 180 degree, cause it was minus r. This is the relationship between rectangular and polar coordinate. Cause the r is a tangent line from the x-axis and y-axis, so the x equal to r cos theta and y equal to r sin theta. From rectangular to polar coordinate, we got the r square equal to x square plus y square, and tan theta equal to y per x, with exception x shouldn't be 0, cause it will be there's no answer. This is the example of the polar coordinate. So first we got the r value, then we got the theta, and cause it was in the quadrant 4, so there's a 2 answer. It can be 2 root of 3 and minus 1 per 4p, and minus 2 root 3 and 3 per 4p. In engineering, we will develop further the polar coordinate between spherical coordinate and cylindrical coordinate. Spherical coordinate is a sphere where the center of the coordinate is the center of the sphere, represented using r, theta, and azimuth, where r is radius from the origin O to P, and theta is the angle between the zenith direction and the like segment OP. If we are familiar with the polar coordinate, then the angle theta isn't too difficult to understand, as it is essentially the same as the angle theta from the polar coordinate. And azimuth is a sign measured from the direction to the orthogonal projection of the line segment OP on a reference plane. Spherical coordinate will be used for when we have a problem with the gravity of the planet or a hydrogen atom. As for the cylindrical coordinate, we will use it when we study mechanical engineering, like fluid mechanics, where we will calculate continuity equation in a cylindrical when the type of the flow is two-dimensional and incompressible, and for which polar coordinate are r and theta. Besides fluid mechanics, we will use it when we have a problem with the magnetic field of the wire or others problem. And this is the real life application. We mainly see it in the radar, like this one. But beside the angle and the radius, there's many other information. Thank you, everyone. This is my presentation.
Okay, Aryan, thank you for your presentation. So, again, any questions? Okay. Anyone? Any students? Any questions for the presenter? Anything to discuss? Okay, maybe I have a questions for Adia. Do you look on how many polar curves that you can find? How many types?
How,
Yeah, how many types of polar curves that you can find?
if I'm not there's if as I remember there's are five.
Mm-hmm. Do you remember what they are?
Uh, I can't remember.
Okay, this polar actually I believe for calculus, especially calculus 2, this will be really important because I will not repeat it in the class. So if you are going to go for calculus 2 next semester, you will learn some of the polar curves. Okay, so let me show you. Let me screen search. Okay. Okay. Let me. Okay. Okay. So first, as mentioned, with the polar coordinates, okay, we will have, okay. So usually we have x, y coordinates, right? This is we call the Cartesian. Okay, in polar we have r and theta. This is we call the polars. Okay. The difference is in the Cartesians you are having y and x axis, right? I think this is already in the Ardian presentation, but let me just remind you. And here there is no xy, and even there is no y. We have just a polar axis, and that is, and that's it. And how we are dealing with the graphs? Usually, uh, if the rectangle or Cartesians they have, they can help with some like this, some rectangular shape like this, which means that every square is 1 by 1 unit. Okay, 1 by 1 unit. It's 1 unit, 1 unit. Okay, so this is 1, this is 1. Okay, and 2 and 3 and 4 and so forth. Okay, in polar, you will have a circle. So maybe from here, maybe let me. Okay, this circle is like a helper. Okay, like a helper. So that means that this maybe in a, this is 1, this is 2, this is 3, this is 4, and still we have more and more and more circles that is helping us. But the graph itself is, we are going to have, for example, if we draw the helper also, this line is another helper, not y-axis. Okay? Remember, in polar, we are going to revert the concept of Cartesians to a polar. Okay. So for example, if you have, let's say, x squared equal 4y, this become our cos theta squared equal 4r sine theta. And you need to finish this off and make it into a polar equation, which is, let's start to solve this. Or we can have 4 tangent theta secant theta. So we call this polar equations. Or if we have just r, let's say 2 sine theta. Yeah, let's say we have r 2 sine theta or 2 cosine theta. We will have, start from, this is the angle 0, and let's say this is pi over 2. Okay, and let's take, maybe this one is pi over 4. And let's write down the 2 sine theta. So when sine is 0, r is 0. Okay, we start from, let me make another color. So this will be a 0 here. Okay, we are not having any radius at all. And then we start to go to maybe sine sine pi over 2. So let's write sine pi over 2, or this is equal to. Okay, so at pi over 2, at this one, we have radius 2. Okay, or maybe let's write with let's say pi over 6. Okay, pi over 6. Pi over 6 probably around here. Maybe around here. So this will be 1. So this should be equal 1. Maybe here. And if you have another one that is maybe 2 sine pi over 3. Okay, this is sine 60 is square root of 3. Square root of 3 is in the middle of 2 and 3, 1 and 2. So maybe it's around here. Maybe this is okay. Okay. So we will have, okay, if you draw, maybe it's not really that clear. Let me draw one more again. Okay, if we have r, a sine theta, a is any constant. So this will be a, and this will be half a. So if a is positive, okay. This red circle here is actually if we have r equal a constant. Okay? So meaning that we will have a different constant that is symbolized by the radius. Okay? For example, if r equal to, that means in a polar we will have a circle with a radius 2. Okay? Okay, so if we have another one, like for example, r is a cosine theta. Oh, sorry. I think this should be cosine because a is in this positive one. Okay, sorry. This is sine theta. If sine, then we start with from here. Okay, this is if a is positive. So if we drew this part here, what we are going to have is actually like that. We connect all the points. Okay, so as we move from 0, okay, let me change color. As we move from 0, we move to here, increasing our angle. And then again, we start going to have, and this is at a pi over 3, and then pi over 2 here. And then increasing another one, let's say we are having another circle until pi. Okay. And until pi, it's going to have another 0. And we stop at this point. And if we increase the theta, so you can check the theta, like for example from 0 until pi. And if you increase this pi, maybe pi plus maybe 5 over 6 or any pi that is increasing after that, you will have another circle that is still on the same sides. Okay? So this will be the a or 2 sine theta, and we can also do the same thing with the cosine. Okay, when the cos is 0, this is 1, right? Or in our case here, it's equal to a. So a cos theta is a. So this is what we start with. Okay, we already have a radius here. Okay, it's different from the sine, which the sine has the at 0, right? At 0 here. But cosine we have here the point, and then we start to move. Going up, as we increase the angle, and eventually, when we have pi over 2 is here, we are going to have 0, and it's going to have the point here. Okay, as we increase, you need to be careful, okay, as this is not x and y axis. Okay, again, this is not x and y axis. So when you read this, it's not the point here. Okay, it's different. How do we read this polar is, so when we have this, this is pi over 2. So we still have increasing here, increasing here, increasing here, increasing here, and that is our point. So how do we read this is, if we have moved from here the angle, if the result is negative, then you need to put the point at the behind of the one that we are considered. Okay, so you will get this from this angle here. Okay, I hope you understand this, because it's difficult to teach. Okay, and if you miss out, not sure on how to teach, okay, and maybe you need to read or explore by yourself. Okay, because this will be in calculus too. So no matter what, you will face this problem. Okay, so this is the first types. Okay, the first curves. Okay, we have a circle that is either we have this r equal a, or we can have also r equal a theta, which is this is becoming a spiral. Okay, become a spiral. And also we have the a cos theta and a sine theta. Okay, and they have another when the a is negative, this will be the circle. And for the cos, the circle will be here when a is negative. Okay. Now that is the first types. Okay. The second type is we call the let's write r cos 2 theta. Okay. This is how it looks like. Okay, and you need to learn how to draw this. So this is 0, this is pi over 2 pi, and 3 over 2 pi. Okay, and let's have help from the pi over 4 here. And another one. Okay, and let's have this as pi over 4. Okay, if we start the cos 2 theta, we start from, let's say we have a cosine graph. Okay? right? And then we start from this is 1, going down, because it's cos to theta, right? So this is pi over 2 here, because 2 with pi over 4 is 0. So it's going to be, this is the negative 1. And then going up, and then going here, and then going down, right? And then going up again, and until here. Okay, this is the cosine looks like, right? Our regular cosine. We need to put this graphs inside the polar. This is the polar axis. Okay, this is the polar curves that we want to make. Okay. Now, from 0, we start from, let's say this is 1. Okay, we start from there, and then we increase the angle until pi over 4, which is pi over 4 is 0. Okay, so it will be look like we need to increase until there. Okay, and after that, what will happen? We will have a negative. Okay, so we will have, or we will meet a negative part. Okay, so we will going to have so pi over 2, we will let me write, this is 3 over 4 pi, this is 5 over 4 pi, this is 7 over 4 pi. Okay, so we will have a 3 over 4 here, and 5 over 4, and 7 over 4 pi. Okay, in between here, these two, because this 3 over 4 pi is 0, and pi over 2 is negative, okay? So what will happen, okay, what will happen, because at pi over 2, they say it's negative, when pi over 4 is 0, okay, so what will be the next sessions? So it should be going to have, if the pi over 2 is negative, okay, let's say this should be the one that we are going to look for. If this is the positive r, okay, the negative one is going to be the backside of the curve, so it should be here. So if we increase, okay, so from 3 over 4, so from pi over 2 to 3 over 4, we will have continuations of the curves. That is sine 3 over 4 is 0. So we will have like this. Let me write a more smooth. And going there. And going there. And then going there. Okay. Now, it's difficult to imagine, but I recommend you to watch some tutorial on YouTube to better understand how it's. Please watch. I will recommend some videos for you on how to draw this. Okay. But what you need to remember is, if we have this cos 2 theta or sine 2 theta, it will have something we call rose petals. Okay. And then the other part of the curves, or the other type of the curves that we have, is r a plus minus b sine theta, or r plus minus b cos theta. We call this Limason. Okay. And in Limason, there are several types. Okay, so we have 4. This is Limason with inner loop. This is the cardioid. This is a dimpled Limason. And convex Limason. And how the Limason is made of, okay? Okay, for example, okay, how to draw. Let me write the example first, okay, and then we analyze what it is. Okay, let's say we have 3 plus 4 cosine theta. Okay, to draw, let me give you a shortcut. Okay, but I hope you get this point. So this shortcut here, okay, if you remember the cosine from the previous circle, let me just remind you what it is. The cosine having a circle on the right or on the left, right? From here, from cosine theta, from a cosine theta. So if you have cosine here, that means it can be on the right and it can be on the left, right? It's like we have some circles there, okay? But it's not literally a circle, but some curves, okay? Some curves, okay? And we have this is a positive, okay? So maybe it will be something here, okay? And this a, okay, it's 3. Believe me or not, this will be 3, okay? This will be negative 3, okay? And then the cosine will have maximum 1, so this should be a 7 when theta is 0. So this should be around 7 here, okay? And how it looks like is it will go through this point 3, and it will crossing here, and it will take the difference between 3 and 4 is 1. Okay, so 4 minus 3 is 1, because when cos is negative 1, or when it's having a differences in terms of 4, or it should be 3 minus 4. This is negative 1, so it's 1. Okay, the difference in the distance. So it should be having, this is 1. And going there, and going there. And that is our Limason. It should be in a smooth way. It should be like this. Okay, it's not very smooth. Should be having more curvy in this point here. Okay, maybe like that. Okay. So that is the inner loop Limason. And we have also, we call the cardioid. Okay, so this is inner loop Limason. The cardioid is if, okay, this is if a over b is less than 1. This is a, this is b. Okay, the cardioid is if a is equal b. For example, r is 2 plus 2 cos theta. This will become like a heart. Okay, so this will be 2, this will be 2, and this will be 4. And this will be 0 since 2 and 2 is 0. So there will be no inner loop. And it's the name itself is came from cardio, which is heart. And it seems like heart, right? And what will happen if we have sign? I forgot to mention. If we have sign, for example, this. Remember the equations before? We have cos. It can be right or left. If we have sign, we will have on the top and down. Okay, depends on is it positive or negative. So if it is positive, then it will be like that, and this will be 2, -2, and this will be 4. Okay, same way if you have this, the cos, then if you have the negative, then the negative will be like that. Okay, okay, that's the cardioid. The other part or the other types is we call the dimpled limaçon. This is if A is greater than B. Okay, so you have A plus minus B cosine theta, or A plus minus B sine theta. And this will be resulted in, the shape is, this is same A minus A. It's similar to cardio, but the difference is this part here is not going to be in the middle or in the origin 0 center, at the center. Okay, and we called it the dimpled limaçon. There are another one, the last one is we call the convex limaçon. This is if A is greater than 2B, so it's really, really large. The A compared to B is really, really, really large. So we will have, it's somewhat going to have similar to a circle, but it has something that is still elongated. Still elongated. So this is A plus B here. This is A. This is negative A. So the more you are having increasing your, so your A first is less than A over B less than 1, and then A is equal B, and then A is greater than B, and then A is greater than 2B. So the more greater A, the more you are going to have a circle. Okay, so first start from the loop like that, having the loop like that, the loop, and then going to have a cardio, and then going to have like a dimple, and then it's going to have similar to circle, and then eventually you will get a circle if you increase your A. Okay, I hope you guys can see the differences. Okay, and that is the limaçon. The last part is we call it the lemniscate. Okay, the lemniscate. There are only 2 cases for lemniscate. This is how it's the equations. The equation looks like. This will be sorry. So this should be like this, like an infinity loop, and this should be A. This should be negative A. Okay, and the other one is with the sign. And with the sign, it's just like this and like that. Sorry. Okay, just like that. Okay. So you have a circle, a spiral. Spiral not really important, not really mentioning a lot, but the circle, the rose petals. Okay, the rose petals. I need you to look on this rose petals by yourself. Okay, and let me later attach some tutorial on YouTube on how we are going to observe this and how to draw this. Okay. And then the next part is the limason. We have 4 limason. We have the inner loop, we have the cardio, we have the dimpled limason, and we have the convex limason. And we also have the last one is the lemniscates, and we only have 2. So whenever you have this kind of equation in polar, you can directly draw something like infinity loop like this. Okay, this is for cos, this is for sine. Okay, and also I'm expecting you to familiar with the how to write down the polar from Cartesian. So from the Cartesian to polar, this is equations to polar equations. I hope you can convert this and also convert from polar to Cartesian. Okay, so don't expect because we still have one final exam, and that final exam will consist everything. Okay, so including this polar. Okay, so hope you guys enjoy the learning system. And for tomorrow, I hope everyone watch your friends' videos. Okay, prepare questions. Okay, I'm really disappointed this for today's class because I think you guys just watch your friend's presentation just now. Okay, so please watch before the class started. Okay, you still have a lot of times. Okay, I think your friends is maybe short video, and some of your friends, some students did really long video, but I think you can still watch it and prepare some questions, or maybe prepare some discussion or maybe suggestions to your friends. Okay, because I'm expecting for this PBL course to be having a lot of discussion in our class, and since you guys prefer online, and this is what we have. Okay, if you have complained why we don't have this and that, because you want to do it right like this way. So if I decided like maybe half of this class is not going to pass the course, then you need to also accept it as my results. Okay, so I think that is for today's class. Tomorrow presentations will be after Adrian is Kenzie. Okay, and if we still have time tomorrow, Kenzie will be with Maria. Okay, if not, then we'll Kenzie just do it alone. And next week, Tuesday, we will start from either Maria, Helen, or start from Helen and Hans and Jordan. And the next the next week, we'll have maybe some break, and then after that, at the beginning of January, okay, we will have a final exam. And for Maria, okay, I need your schedule. Okay, I need your schedule for all either basic math or calculus part, and all your available schedule. I send you an email. Please reply those email to me. Okay, we will have a schedule for some exam for you, especially this basic math. Okay, we will arrange the schedule. Okay? And for the other students, we will have an exam, final exam, physical final exam. Hopefully on first week of January, maybe 4 or 5. Okay, but if you have other schedule for other courses, we will have on maybe other 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 dates, like maybe on, check this, maybe on Thursday or Friday if you have time. Okay. But if not, then we will just keep on 4 and 5 January. That will be the final exam, unless you tell me there is no QR code for attendance for today class. I expected everyone to come on the presentation, even though still there are students who are not present. Okay, so that will be resulted in your scoring. Okay. Okay, so that's it for today. I will stop the recording.